How is your preparation going on?
Good, sir.
Okay. Did you? So week 9 deadline is done, or it's after quiz second
Tomorrow, tomorrow.
Tomorrow, sir.
tomorrow?
So can you please exceed the dates after quiz two?
No, for quiz 2 it will be from week 5 to 8. So
Yes, sir.
focus on, yeah. So focus more on like equal. This is like more or less equal weightage, but you can focus more on. Uh, See, the from week 5 to 8 is more or less interrelated. Okay, interrelated. I mean, if there is a question from the continuity, so whatever I have seen, like if you have a question from the continuity or discontinuity, there can be any function. Okay, there can be any function that can be using the concept of f of g, or maybe the log function. So it's like more or less it's like equally weighted, but yeah, continuity and like derivability or limits, those are from the week 7 and 8, is having a good chunk. But if you are aware of the concept of 5 and 6, then only you'll be able to solve the problems from week 7 and 8. Are you getting my point? So it's like more or less equal weightage. You can, if you'll see the paper, you'll be seeing that from each of the week, each of the questions will be consist of the concept from at least 2 to 3 weeks. Okay, so there's no point of leaving any of the weeks. You have to go through each and every week. And for at least what I can assure is, if you are just going through the today's lectures, we'll just go through the week 5 and 6, and whatever the questions we'll be solving, if you're able to do that. But if you're not able to do that, also just be focused here. And after that, I guess you'll be able to solve the paper in the quiz also. Okay, so at least whatever the question we will be solving here, 10 to 15 questions, so that you should be knowing, and at least those type of questions you should be aware of, and you should be able to solve those type of questions. Okay, that I can tell you. And then the next session will be taken by the other people, so he'll be consider like telling you about the last 2 weeks. So today we'll just go through the week 5 and 6. Okay. Not aware of that. Like, what are you saying? The 3 p.m. lectures. I don't know. What was that? Was that for the maths one or some other?
So at 3 p.m. was PYQ lectures.
Okay, that
Oh,
was done by
Pilot
TAs.
PA.
Huh?
yeah, and recording was available.
Okay, okay. So yeah, recording is available also. Yeah, one more thing is, please go through the previous term paper, at least 2 term, January and May. Please go and solve at least those paper. You can just take out the quiz 2 paper and solve the paper, okay, of January and March. That will help you a lot.
Sir, I have some doubt in concepts of 5 and 6, which I'm facing while solving a activity question. I have certain questions related to that also. So after you discuss that week 5 and 6, can I ask those?
Yeah, yeah. Will I hope after discussing your whatever the doubt you have will be clear. But okay, if you have the doubt in the end also, you can ask me. First, we'll go
Okay.
through the week 5 and 6 concepts. The concept that I feel is important for the paper. After going through the paper, I just
I
prepared some
have doubt
slides.
in concept only, sir. It is
Yeah,
related
yeah,
to not to question.
yeah, yeah, yeah. I'll be discussing the concepts, and then only we'll be discussing the problems. Okay. So I'll start till, I'll just wait for 3 4 more minutes. I'll start by 8:10. Okay. I'll just wait for some more people to join, and then we'll start. Why the number of crowd is very less? Mhm. Are you able to see my screen?
Yes, sir.
Okay. So I'll just wait for 2 minutes, 2 more minutes, and then we'll start. Okay, so till that time, I'll just the weightage you are already aware. I already told you the weightage. That weightage it will be equally weightage. Okay, so the weightage will be week 5 to 8, 25% from each week. Okay, and what I can tell you is like week 5. Okay, week 5 and week 6 I'm going to discuss. So I'm telling you some of the important concepts that you should be knowing. Okay, so you should be knowing the increasing and decreasing function. Then you should be knowing 1 function. Okay, and the most important part is f of g. Okay, for the composition you have to calculate, you should be knowing how to calculate the domain of any function. Okay, domain of any function means f of g, you can be given fx, you can be given gx, and then you need to calculate the domain for that function. Okay, and the other part is okay, the simple function you should be knowing, like any exponential function. You can be given some equations that you have to solve, like 3 to the power x minus 2 into 3 to the power x plus 1 plus some alpha equals to 0. Then calculate the solution, calculate the number of solution, or maybe calculate the value of x. Okay, and is the screen, my screen is visible, right? But this is fine for that one. This is clear, right?
Yes, sir. Yes, sir.
Yeah. So these are the concepts that you should be knowing from the week 5. How to know about whether the function is strictly increasing or decreasing, or whether the given function is 1 or not. But this function won't be that difficult. This function will be whatever has been discussed in the lecture, like for example mod x, or any exponential function or log function. So this type of functions will be there. There won't be any difficult function that will give you, that will be difficult. Okay, so whatever has been discussed will be there in the questions.
Sir,
And
can you just zoom out?
okay,
Just a little bit of zoom out, not zoom in.
okay,
Yeah, sir. Now it's okay.
this fine.
Yeah.
Okay, okay, so shall we start now?
Sir, it seems the Zoom link is not working, and that's why we were facing issues to join in. So we used the meeting ID right now, and then we were able to join. So I
Then
just
you
Okay,
can
what
join by
can you,
meeting ID.
yeah.
what?
I think sir, I think the Zoom link that is there in the calendar, it is broken because we are not able to join through the link. Join through the meeting ID.
Okay, how did you join? Like, how did the
I
people,
joined
Meeting
whoever
right
is
ID.
now.
there?
I tried it with the meeting ID and the passcode that is mentioned down there. But normally, what we do is we join through the Zoom link.
I have joined
Okay,
using that.
so in the
Yes,
calendar,
yes, yes.
whatever
I
has
also
been
joined using the
updated,
meeting link.
No, I'm just asking you the
Sir,
calendar
in the
that has the link.
calendar, the link which was updated is not working. So we have to
Yes,
join
sir.
But
using.
okay, but I joined it from the calendar link only.
But it's not working now, sir.
But
But
it's
it is
not
not
working
working
for
now,
us.
sir.
Not working. Huh?
Yeah, because of that, I could see some of the comments on the YouTube live as well that they are not able to join in.
Okay, let me check it then. Yeah, Mahesh. So some people are saying that they are not able to join it from the Zoom link. I guess on the YouTube they are commenting. So is there any issue with the Zoom link? Oh, some people. Okay, there's no problem. Oh, okay. Because some people in the session also they are saying. Uh, okay,
Yes, sir. Link is not working.
link is not working. Huh?
I
Okay.
also use the meeting ID and the password to log
Same,
in
sir.
the
The same.
meeting.
I also use the meeting ID and passcode.
Me too, sir.
Yes, I also joined using the meeting ID.
Okay. Hmm. Okay. Just wait for some 2-3 minutes. I'll check.
Sir, I think there is a space is needed after meeting, after the word meeting. That hyperlink is getting into meeting. That is the reason people are.
Okay.
Sir, but if we are just copying and pasting the link without just clicking it, then also it's not working, sir. Maybe there's a typo in the site.
Okay.
Actually, the link starts from zoom.us. That online degree hyphen thing is not there, should not be there.
Yes, sir.
Yeah, so we'll start now. I guess I've already talked to the team. They've told that maybe in the calendar there is an issue, but that we can't correct it now. But okay, if somebody doesn't watch it, they can watch it on the YouTube, I guess. Okay, shall we start now? It's already we have 20 minutes down.
Yes, yes, sir. Please
Okay,
start.
let's start. So I'll just start sharing my screen. Okay, so I'm just talking about the weightage. Okay, so this is the weightage that has been there for the quiz 2. So for
So
the
what
quiz,
about for week 1 to 4?
yeah. So it's like I'm telling you, this is from for quiz 2. You have a weightage from quiz week 5 to 8. Okay, only we need to go through from week 5 to 8. Okay.
So week 1 to 4 content will not come now.
Yeah, there's no, see, as such there won't be any content from week 1 to 4, but okay, one thing is like if some concept has been used from week 1 to 4, you can't say that this is from week 1 to 4. Specifically it will be from week 5 to 8. See, some concepts are there, like one function has been taught in first lecture, like first week also, that you can't say that's coming from week 1, because it's already been discussed in week 5, right? So there can be some concept that that you are using it, the concept has been used from week 1 to 4. You can't totally what you can say, like week 5 to 8 you can't it's like not totally independent of week 1 to 4, right? But most, like all the questions will be from week 5 to 8, but yeah, some concept, if some concepts are there that has been used while solving the problem of week 5 to 8, that you can't say that it's coming from week 1 to 4. Okay, did you get the point?
Yes, sir. Yes, sir.
Huh. So this I was talking about week 5. I already told you the important things that you should be going through. Okay. These are the topics that you should be going through. Okay. I'll start with the week 5 content. This is clear, right? This you're able to see the screen nicely.
Yes, sir.
Okay.
Yes, sir.
So we'll start with the week 5. Okay. So the first basic thing is, how do you know whether this the given equation or the relation is a function or not? So there is one method that you already aware, most hopefully you're already aware of this, right? Vertical line test.
Yes, sir.
Correct. So how do you check that? How do you do that? This vertical line test.
So passing one vertical line
Yeah.
at
So
point 1.
correct. So you just have to draw a parallel line parallel to y-axis. You just have to draw a vertical line parallel to y-axis, and if that line intersect the curve, okay, if that line intersect the curve more than once, then you can say that this is not a function. Okay. Let's, for example, there is an equation like this. Is this a function?
No, sir.
No,
Yes.
sir.
It's not a function, right? Because if you're dropping a vertical line, it's not a function. Okay, so yeah, check for this question, and yeah, this type of questions can be there. So whatever, like maybe it will be more than 10 questions, so every question is important. So each of the questions can be similar type of problems, or some concept from this of the problems can be there in your options in your quiz paper. Okay, so all this whatever I'm discussing today is very very important. Everything is important. Okay, you have to check whether this is a function or not. Can somebody tell me whether this is a function or not?
Yes, sir, this is the function.
Yeah, how did you say that this is a function?
So first we have to check for log 3x. So log 3x is a function and it is the greatest integer. So we this should be
Not a
between.
greatest integer, yeah. So first of all, this is not a greatest integer.
Okay.
It's just a
So
function. So I by mistaken I just wrote it like this. This is like this. Okay, this is the sum f of g function.
okay, so we have to check for log 3x and this domain and that thing and just check for the graph. Like
Yeah.
we have to plot log gx graph if possible. That's it.
See, okay, so
Sir, we can
okay,
directly tell it by the composition, right? Log 3x is function and log base 2 is also, so the composition will also be a function.
yeah, you can say that. So whatever you have said is absolutely right. Okay, so this is a function. Okay, even though you are not aware of that, this is coming under a log function. Log function, you are already aware of that, right? It is okay. Log function is increasing or a decreasing function?
It's increasing.
Increasing.
The increasing
Increasing.
function. Okay. Basically, what does log do? Log will just, it's like amplification, some type of amplification it does, right? Log function. So whatever your values, that values, see, for example, earlier, if your log x is equals to 3, what are the values you will be getting? Log 3. So earlier, we are putting it here, you'll be getting 1, right? If your x
1.
equals to
Yes, sir.
9, you'll be getting log 3,
2.
9 equals to 2. So basically, this is like, it's not amplifying, it's amplifying in the opposite way, correct? It's just excusing your values, right? Log function. So this is what basically log. So many a times, whenever you'll see in the upcoming like courses and all, you'll be seeing that log function is used so many places just to excuse the, like, to like excuse the values. Okay. So here also, this function, if you are just aware of that, this is a function. Okay, log x is a function, right? And then again, you are applying the log function here itself. So this is a function only. So you can directly mark it as a function. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So in the same problem, if I'm asking you, okay, later I'll be asking you after discussing that. So this is a function, correct?
Yes, sir.
Is this a function?
Yes, sir.
Yes, sir.
No, sir.
Is this a function?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Downward
sir.
parabola.
Yeah, so it's a upward or a downward parabola?
Downward.
Downward, sir.
Downward.
It's a downward parabola,
It's a
correct?
function, but it's not reversible.
It's a downward, what reversible? What did you say? Okay, one more thing. If I'm asking you, this is your fx, okay, and this is your gx. Now tell me the value. Now tell me the value f of gx, and the maximum value of this. Can you calculate?
Yes.
How did you calculate? Just tell me the procedure. How will you calculate?
So first we'll calculate the maximum value of the quadratic equation,
Okay,
Sir,
first
we
you'll
find the-
calculate the maximum value of
which is
gx.
2.
Okay, that is 2. Okay, and then you'll put it here, right? So this is what I was saying in the starting. Log for any function, whatever the function, let's, for example, this is the function. So if you are getting the maximum value at some particular value x, so for this function also you'll be getting the maximum value at that particular value itself, correct or not? So if you are getting, so at what time you are getting 2, at what point you are getting, at what x equals, you are getting y equals to 2?
Sir, x equals to 2 and y is equal to 81.
Y is equals to 81, right? Okay, so you'll be able to calculate this, right?
Yes, sir.
Yeah. So any problem in this? Anyone is having any issue in this?
Sir, how to find maximum value in this function minus x square plus 4x
How
plus
do you find? Okay, so okay, tell me, how do you find the at the
in
point
the quadratic?
the maximum? Yeah, in the for the quadratic
First we
equation, how
find
do you
the
find?
axis of symmetry. First we find the axis of symmetry.
No, this
You
point
can find maximum
minus
value
b
by
by
the
2 is
formula minus b by
some
2.
formula is there, right?
p minus b
Yes,
square
sir.
by
I am
4.
also saying about this, sir.
Yeah, so you can get
Then
it,
put
or
the
what
value
you
of
can do is,
x in the
b
function.
minus b square by 4.
so now you have already read about the differentiation, tangent, everything, right? So for for any function, for any quadratic, if the function is like this, if you are able to plot this function, and now you are already aware of the differentiation, so now you can say that at this point, wherever the function is maxima or minima, at that point the tangent will be parallel to x-axis, right? Or the slope of this tangent will be 0, correct? So what you can do is you can differentiate it and equate it to 0, correct? And then at whatever the point you are getting x equals to some x star, that will be the point where the function is getting maxima and minima, correct or not?
Yes, sir.
Right?
Yes, sir.
So you just have to find the point where the tangent has a slope 0, and at that point you will be having the maxima or minima. That point you can put it here to get the maxima or minima, correct?
Yes, sir.
Yeah. So this is what basically you have to do. So here also minus b by 2a comes from this equation only. Whenever you will be doing this, x square plus bx plus c equals to 0. If you are calculating the differentiation of this 2ax plus b equals to 0. So x is equals to what? Minus b by 2.
Yes, sir. The slope is also come from this. Then you are not audible.
At that Yeah, are you able to hear me now?
Yes.
Yes, sir.
Yes, sir.
Okay. So I was asking, is there any problem in this equation? Like the first question, whatever we have discussed?
Sir,
Yeah.
sir, you said earlier that if gx attains the maximum value, then f of g should attain maximum value, right?
Yeah, f of g. See, if you already aware of what? See, log function is what? Log is an increasing function, correct? So if you have, so you have some function gx, and gx, the maximum value of gx is 5, correct? So if you are putting log 5 only, then at that point also log 5 will be maximum, right? See, for example, you have gx equals to 3 also, 3, 4, 2, but your maximum value is 5, right? So if you are putting 5 here, then only you will be getting log 5 as a maximum value, correct? F of g, correct?
Yes, sir.
Sir, only
Yeah,
in
this
this
is what
case,
I was.
like if we change the effect, if we change my
Yeah,
function.
if you are changing the fx, then it will be different. I was just talking about the log function only.
Okay.
Yeah, because log, we are already aware of that log is a increasing function, that's why. One more condition, a is bigger than, a is already greater than 1, right? Okay. Why do we do horizontal line testing? Why do we do that horizontal line testing?
To check whether the
function
is 1 or not.
To check function is 1 or not. What are the other method that what are the other method to check 1 or not, like 1 function?
Inverse.
If
Correct.
if x1 is equal to x2, then f of x1 is equal to f of x2.
Correct. One information has been given to you. Okay, so first I'll talk about the horizontal. So in the horizontal line test, you just have to plot whatever the function is given to you. You just have to plot that function. Okay, and after plotting the function, you just have to drop a horizontal line. Correct. Let's, for example, you have this function. This is a 1 function.
No.
No.
No, sir.
Is this a function 1 from the domain 1 to infinity?
Yes, sir.
Yes.
Yes,
Yes,
sir.
Correct. So yeah. So from here, I told you if you have the plot itself, you can just drop a horizontal line parallel to x-axis, and then you can say if it is colliding at two places, you can directly say it's not a one function. But if the domain has been given from 1 to infinity, that you can say that if you are dropping any horizontal line, it will be crossing the line at one point itself. So that's why it's a one function. Okay, and how do you check whether the function is an increasing or a decreasing? What? Okay, first tell me what is the difference between increasing function and a strictly increasing function. What is the sufficient condition for 1 Is it an increasing function or is it a strictly increasing function?
For
It's a strictly increasing function.
Increasing.
But it can be both. It depends.
No, it should be strictly increasing. See, for the increasing function, what is the condition? For the condition is x1 is less than equals to. So here the equality is holding. For 1 is the equality. If the equality holds, whether the function will be a 1 or not.
No, sir.
No, right? So you already told me for 1 function, if fx1 is equals to fx2, then x1 must be equals to x2.
Yes, sir.
Right? But for this condition, if I'm plotting an increasing function, this is an increasing function. Is this a 1 function?
No.
No, sir.
No, right? But you can see that from here, this x1 and this can be 1 x2. So here the function value is same, right?
Yes, sir.
But is the x1 equals to x2?
Not, sir.
No, right? So that's why,
No,
so
sir.
the sufficient condition, right? That should be the function should be strictly increasing, not only the increasing function, because this is also increasing function, right? Increasing means what? It is an increasing function. It's generally increasing, just increasing function means non-decreasing, right? It's not decreasing, but for some point, some interval, it can be a constant function, right? So here also you can see that from x1 to x2 is a constant function, right? So the function
Yes.
value is same from x1 to x2, but x1 and x2 is different. That should not occur in 1 function. This is what I was trying to say you, that you have to check whether the function is a strictly increasing or not. Is this clear to everyone? Okay, I'm just asking you, if I have a function that is a strictly decreasing function, whether that function can be a 1 or not.
Yes, sir.
No,
That
sir,
function also can, that function also can be increasing function. Sorry, that function also can be a 1 function, right? Because for a strictly decreasing also, you can imagine in your mind that if you are dropping a horizontal line, always it will be crossing at one particular point only, right?
Yes, sir.
Yes, sir.
Right? See, this is a decreasing function, right? This is a decreasing function. If this is a decreasing function, you can drop any line, it will be crossing just one particular at one only at one time. Okay.
So the last one which you had drawn, no, that is a strictly decreasing or it's just a decreasing function?
It's strictly decreasing.
Okay. If
See,
it was
only decreasing will be like something like this. Okay.
where the f of x will be same for x1 and x2, different x2.
Correct. You can see that from here to here, the function value is same, right?
Okay.
From x1 to x2.
Understood.
Sir,
Yeah.
then x cube will be strictly increasing or means decreasing or increasing, right? It's one function, right?
Yeah. It should be a strictly decreasing or a strictly increasing. Okay. It can be a 1 function.
Sir.
Yeah.
Sir, in increasing function, a constant function will be available.
Increasing, the constant function is not a, you can say that it's increasing function because at all the points will be like the value will be constant, right? Like it's
Oh,
a non-decreasing type of function. It's not a strictly increasing, nothing like that. Okay.
okay, sir.
Sir, if it's like, is it like a postulate that if it's strictly increasing or decreasing, it would be 1 1 only?
Yeah. If you are able to know that, it's not like it should be both. It should be either of the
Yeah,
two.
it would be one, either one. Yeah.
In whatever the domain it is, it should be increasing or decreasing. It should not be both. Otherwise, so you can drop like this function, right? This is also
Yeah.
for this interval, it is an increasing function, and then again it's a decreasing, and then again it's a increasing.
Yeah. So
But if
the
you have been
domain
asked,
matter basically.
from this point, let's for example, this is some x1, and
Yeah.
from x1 to infinite, if you have been asked, then it's an increase. Like you can get the inverse of this function or a 1 1 function, right?
Got it.
But if you have been given for all the domain, you can't say that, because it's increasing, decreasing, increasing. So you can't say anything about that.
Got it, sir.
Yeah. Tell me about this function, whether this function is a 1 1 or not. And
No,
see,
sir.
any of the function that will be getting in the exam won't be any difficult function, that I can assure you. After going through the whole paper thoroughly, I'm telling you. So whatever has been discussed, whichever type of function has been discussed in the lecture, only if you are able to know about those functions only, you will be able to solve all the the questions. There won't be any difficult function that you haven't seen in earlier. Okay.
No, it's not a 1 1.
Yes, sir. This is not a 1 1
This is
function.
not a 1 1 function.
You can draw this, right? You can draw this function, right? And if you are drawing a horizontal line, it's crossing at 2 point, correct? Okay, now tell me whether this function from 0 to infinite, is it a strictly increasing or not?
Yes.
Sir, it is
Yes,
Yes, sir.
Okay, and from minus infinity to 0, this function is a strictly increasing or decreasing?
Strictly decreasing.
Decreasing, sir.
Decreasing.
Correct. So if you have been asked for the same function in some particular domain from 0 to infinite or minus infinity to 0, we'll be able to say that that's the function. And one more thing, if this is a 1 1 function, then you can get the inverse also, right?
Yes, sir.
Yes, sir.
Invertible. Yeah.
Okay. Now tell me about this function, exponential function y equals to ax. Is a 1 1 or not?
Yes.
Sir, it is a 1 1 function.
Yes,
Yes, sir. That is a 1 1.
Yes, sir.
Okay. No, but the information is not correctly given, I guess. See, a can be, if let's for example y equals to 2x, and then you have y equals to half x. No, I guess for both the cases it will be same. At least one will be, yeah. Okay, first tell me about this one, y equals to 2 to the power x.
Yes,
It
sir.
is
It is
strictly
1 1.
strictly increasing.
It says strictly increasing or decreasing?
increasing.
Increase.
Sir,
Increasing.
Increasing.
How do you plot this type of function? How do you plot this?
We can
Can
take.
somebody say
Yeah,
how
this,
generally you plot this function?
Sir, put the value x equal to 1, 2, 3.
So we're substituting values of x.
Okay, see, what you can do is, at least you should be, see, I told you this earlier also, whenever you have been given a function and if you are not able to get the idea, one is put the extreme values. Okay, put the extreme, x equals to minus infinity, x equals to 0, x equals to infinity, and then get the idea. If you are putting x equals to minus infinity, what is the value you are getting?
0.
0. So it will start tending to 0. Not exactly 0, but 2 to the power minus infinity will be something tending to 0. 1 upon 2 to the power infinity. So if you are multiplying 1 upon 2 infinity number of times, it will start decreasing, right? It will start tending to 0. Correct? Okay. And if
Yes,
x
sir.
equals to 0, then what is the value of y? If your x equals to 0?
1.
1.
Y.
And if you are putting x equals to infinite, what is the value you will be getting?
Infinite.
Infinite.
Yeah, so you can plot now. If you are getting this type of function, you will be able to plot it. See, at minus infinite should be 0, so somewhere here. So at minus infinite, the value should be closer to 0. at x equals to 0, it should cut the function, and at x equals to infinite, it should be infinite, right? And then you can just match it. Correct? Is this a strictly increasing or a decreasing function?
Increasing
Strictly
function.
increasing.
It's an increasing function, right? You can't get a 2 value, right? If you are changing the value of x1 and x2, you'll be getting a 2 different. So if you are taking x2 greater than x1, it will always be fx1 less than fx2. Correct?
Yes, sir.
Is this clear to everyone?
Yes, sir.
There won't be,
Yes,
yeah.
sir.
So this type of function will be there and not get confused in the exam. And so you have, yeah. See, this is some of the laws of exponent that you should be doing. Okay, that I'm not going to discuss. Yeah, and now you have been given a one question that you have to tell me the answers for this. Okay, so you have basically 6 options. You have to tell me how many of them are correct, and this is very important for your paper.
So is that alpha?
What one?
Alpha raised to x? Is that f of x
This is
equals to
alpha to the power x, and alpha is some value greater than 5.
Okay.
The sixth is not correct. Rest all are correct.
Okay, let everybody solve this.
The sixth one is not visible clearly. Can you a little bit stop? Yeah.
Is this clear now?
Yeah, thank you.
Yes, sir. 6 is not correct.
Sir, please explain the point number 3 and 4.
Everybody has tried?
Yes, sir.
Okay. The first option, okay, the same plot you can do, you can take it like this, 6 to the power x. And if you have plot this, you'll get the same type of graph, right? Correct?
Yes, sir.
Yeah, so you'll be getting something like this. 6 to the power x. So the domain for this is R, right? You can put any value minus infinite to infinite. So first one is correct. And the range would be from 0 to infinite. The second is also correct. And it's a strictly what? Increasing function.
The range would not be 0 to infinite, right? Second
Why?
is, so because alpha is taking values greater than 5.
No. Alpha is taking greater than 5, that is fine, but you will be having C2 or x, right? If you are putting x equals to 0, x equals to minus infinite, what is the value
yeah.
you'll be getting?
Yeah, correct.
Will be the range will be from 0 to infinite. It will be strictly increasing. It will be a continuous function, right? Continuous. Why continuous?
A smooth curve.
Point number 3 and 4.
No breakage in the graph.
Yeah,
So
no
it is a
breakage
smooth
in the
curve.
graph.
Yeah.
And if you are tending x tending to infinite, function is also tending to infinite. And if you are tending x is tending to minus infinite, the function should tends to 0.
0.
Okay. Is this clear to everyone?
Yes, sir,
If you have any doubt, you can ask me.
In this question.
Yeah.
Sir, continuous function, can you discuss for this question?
Okay. Yeah, so for this function, see, whenever you are plotting any function, if there is no breakage, okay, so the same thing as whenever you are plotting any function, and if you are not
breakage or lifting of pain.
Yeah, the same thing you can say. No lift if you are not lifting your pain, okay. If you're in
Okay,
one
sir,
go
got
itself, if you are able to draw this, you can say that is a continuous function. Okay.
Okay, sir, got it.
And the most important part is the composition function. So that I can tell you directly is there will be questions,
Sir, I have a
questions
question,
from this
sir.
topic. Yeah.
Sir, point number 3, strictly function. Like, what do they
Strictly
mean by it?
increasing function. Strictly increasing function.
Okay. Thank you, sir.
This one was for the second interval that we are saying now, when a is greater than 1. But for a which is between 0 to 1 interval for exponential functions, It would be strictly decreasing, right?
Yeah, if your alpha is less than 1, then it will be strictly decreasing function.
Okay.
It will be, the function will be something like this. It will go like this. If it is 1 upon 6 to the power x. Okay?
Yes.
Is this clear to everyone? Whatever we have discussed, is it clear to everyone till now?
Yes, sir.
Yes, sir.
So what I can tell you, like, if you are not very much confident in these weeks, at least you should be going through this lecture, okay, and at least solve all the questions that we have discussed, that we are discussing today. All the questions. You should be knowing all the questions, okay. And this
Sir,
is the
will
most
you,
important part. 2-3 problems will be there from this portion itself. Composition of function. That you should be doing thoroughly, okay. From wherever you are getting the question, just solve that. Previous term, or maybe the credit or practice, wherever you are getting the composition of function the question, just solve it. Not that difficult, simple one only, but you should be knowing the basic concept, okay, how to calculate the domain and all. Okay, let's discuss this. Okay, can somebody tell me what are the domain for this type of function f of g? Just let me know. I have written it everything in the, so that you'll be able to understand. There is no, I didn't wrote it in the mathematical functions way, because in that way some people get confused. So that's why I just wrote it in the very simple ways, that if somebody just going through this slide itself, will be able to understand. So what is the domain of this function f of g?
sir, gx?
What gx?
Ra-
Domain of f of g.
Range of gx.
Yes, sir, range of gx.
Yes, sir.
Range of gx?
Yes, sir,
R,
every time
R, I guess.
it
R.
is reverse.
No. I'm saying,
Sir,
see, for
for
any particular, yeah, go ahead.
There are two cases in for f of gx. Whenever we want to find the domain, if the range of g is a subset of the domain of f, then we consider the domain of g
Correct.
as the domain of f of g. And in the case 2, if it is not the subset, then we need to make some elimination in the domain of in the range of g, or in the domain of G. We'll have to make some eliminations, like it depends on the question that we have. So these are the two main cases.
Okay.
Yeah.
Yeah. So I'll again see, domain for this type of function is basics. You have to set of, see, whatever I have written, domain is a set of all x such that x is in the domain of G. First case is whatever the x you are taking, that should be the domain of gx. The first case. Okay. And the second case is, if you are putting that x, so let's, for example, you are taking x1, and if you are putting inside this g, so gx1 should be the domain, should be gx1 should be in the domain of f. Okay, so see, I will repeat it again. So for any composition function, if you have to calculate the domain, you have to take care of all those values. First case is, you have to take all those values of x where gx is defined, the first case. And the second case is, you have to take care of, you have to exclude, remove all those values of x where gx, whenever you are applying that gx, then if that is not inside the domain of function fx. I'll repeat it again. You have to, the domain of this type of function f of g is all those x, set of all x such that x is in the domain of function gx. That is the one case. Okay, so this is the very simple one. You just have to take all those values. So basically, first you have to calculate the domain of all those x. You have to calculate the value of all x where this is in the domain of gx. The second case is, you have to take care of all those values of x where whenever you are applying gx, that should be in the domain of fx. You can't take any gx where that is not in the domain of fx. Did you get the point? See, let's, for example, you have a function fx equals to 1 upon x minus 1. So you can't take any particular value of gx where 1 upon 0 is coming. Did you get the point or not?
Yes.
Or should I solve it with some example?
Sir, can I
Sir,
ask
an
something?
example would be a better.
Okay,
One
let's
Can I
start
ask
discussing.
something in this?
Yeah, you can ask.
Sir, that means that like if we are excluding the 1/0, that one x minus 1, so g of x1 should not be equal to my 1, right?
I didn't get you. Okay. Let me explain with some example, and then if it is not clear after that also you can ask me. Okay.
Okay, sir.
Yeah. So I just wrote it here also. You have to take care of two things, right? The first thing is, if x doesn't belong to the domain of G, then that x doesn't belong to the domain of f of G. So that is the first case. Okay, what is the first case? If you are getting any x that is not in the domain of Gx, then the first sure that is not in the domain of f of G, because that is not going to satisfy the condition. So that's the first case that should be taken care of. And the second case is what? Exclude all x whose Gx is not in the domain of f. Okay.
Yes, sir.
Yes, sir. This is what I was
Yeah,
trying
Now
to
solve this
explain, like
basically
eliminate
that's
the
the
elements from.
so basically that's the range of Gx only, right?
That's the range of Gx.
Yeah, sir, the values that Gx would take inside f of G.
See, that is the range of Gx. Okay, but that range of Dx, you have to remove all those values from the range of Gx where the function fx is not defined, right?
Yeah, correct.
Correct.
Oh,
So
okay.
that you have to remove. See, for example, here you have to calculate. Let first tell me what is the f of Gx ka domain. You have to tell me the domain of this function. So what is the two condition that I told you? What is the first condition?
Sir, it will not
Remove.
take value 0.
Yeah,
and
remove all x
Which are not in the domain of Gx.
correct. Remove all x which are not in the domain of
Gx.
Gx.
yeah, not in domain of Gx. Okay, so which x you will be removing from here?
So 0.
0.
You will be removing 0, correct?
0, sir.
Now what is correct? What is the second case that you should be taking care of?
So
We will
removing
be
all
removing
the
also
x which are not in
the
the
second
domain
case.
of fx and gx.
Also
So
one.
0 and 1 will not include.
Yes, sir.
So 0
0
and
and
3,
3,
we will
yeah.
not include.
Yeah, 1 is included.
0 and 3.
One is included.
0 and 3 you will be excluding. So you have to take care of all those values of x where Gx is equals to 1. See, did you get my point? So see what is been written. Exclude all the x whose Gx is. So you have to take care of Gx x whose Gx is not in the domain of fx. So what is not in the domain of fx? Tell me.
1.
1. So what you have to take care of? You have to remove all those values of x where Gx is equals to 1. Right? So you have to exclude. This should not be there. This x should not be there where your function Gx is equals to 1. What is that
Yes.
value?
3.
3. Correct?
3.
Is this
Yes,
clear
sir.
to everyone? Or if you want
Yeah.
to explain, like if you want me to explain it again, I'll explain it.
So please
No,
take
no,
another example.
So can we find domain after finding the f of Gx?
Okay, find it fair. See, for some cases you will be able to calculate it, but I guess you'll get stuck somewhere. So it's better to take care of all these two cases. Okay, so calculate the f of G for the same function.
2x
Calculate
by
f of
3
G.
minus x.
2 by
2
2x by 3 minus
3
x.
by x
2x by 3 minus
minus
x.
minus 1.
So you are getting what?
Yes.
2x upon 3 minus x.
For this function, if you're just applying f of g, then so your domain should be r minus 3 only. Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Is this correct? No, right?
No.
No, sir.
Your answer
It
should
would be
what?
coming. One would be coming.
0, 3,
The
right?
0 and 3 both should be
तो
excluded.
0 लेंगे तो 2 into 0 हो जाएगा, तो इस 0 और 3 दोनों को इंक्लूड करेंगे.
Yeah, that is what I was saying. You should not be calculating f of g directly and then calculate domain. Okay, you have to take care of both the cases. Is this clear to everyone? Or if you want me to explain me again, I'll explain it. But you will
Sir,
be getting
can you
similar type of
explain
problems
once
in the
again?
exam. Okay. See, what I was saying is you have to take care of two things. For calculating, to calculate domain, okay, of f of g, you have to take care of two things. The first thing is you have to exclude all x where gx is not defined. Okay, and the second case is you have to exclude all x where gx is not in domain of fx. Two things you have to do. You have to exclude all the values. So from, if you will see the first case, you will exclude which number?
0.
0, right? Because 0, see, you have to exclude all those x where gx is not defined. So gx is not defined at what? 0. So you will be excluding 0 from here, this side, from the first case. Now the second case is you have to exclude all the values of x where gx is not in the domain of fx. Okay, so what is not in the domain of fx? First, let me know what is the not in the domain of fx. 1, right?
1, sir.
Correct. So that should, so you have to take out all those values of x. So you have to take out all those values of x where gx is equals to 1, right? See, because see, you already know that f of g of x, so this gx should not be equals to 1 because f1 is not possible, right? If f1 is not possible, that means you have to remove all those values of x where gx is equals to 1. Correct?
Yes, sir. Yes, sir.
Yes, sir.
It's clear, right? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Got it.
Okay.
Sir, if you
Now
don't
then
mind,
what?
can we take another example? One more example.
Can you please scroll down to write the point?
You can write it the point. Okay, let me think of some example.
So the domain of f of gx would be all real minus 0 and 1, right?
Yeah, all are minus
0, 3.
Except 0 and 3.
Yeah, 3, correct. Thanks.
Is this clear? Did you wrote this?
Yes, sir.
Okay. You can take this example fx solve this one.
So we have to find f of g or g of f.
F of G only. Domain. In one line, you have to just tell me what should be how should we approach for this
Sir,
question?
R minus 1
R
by 2.
minus half, sir. Answer.
Correct. So basically, you have to remove which value? So you have to just
Minus half.
because okay, that is fine.
Which value
For
gx is
gx,
3.
so there should not be any value, right? Because gx will take all r. But for fx, you have to remove all those values of x where gx is equals to what?
3.
You have to exclude all those values of x where gx should be equals to 3, correct?
Yes.
Yeah. So you have to exclude all those values of x where gx is equals to 3 because f3 is not possible, right? F3 is the f3 possible? No. F3 is not possible. That means you have to exclude all those values of x where gx is equals to 3. So here also you'll be doing the same thing. So 2x is plus 4 equals to 3. 2x equals to 1. Sorry, minus 1. So x equals to minus 1 by 2. Correct? Now solve this one more question.
Sir, so what was its answer?
R minus half.
Done, sir.
Sir, but as per rule 1, x should not be equal to minus 2 also, na, sir, because g of x will become 0. Oh, okay, okay. I got it. Sir. Thank you.
No, for gx there is no condition. Yeah.
Yeah. Here in this sum there is no condition. Thank you, sir.
Now tell me for this fx equals to 2 upon x plus 3 and gx is equals to 1 upon x.
R minus 0 and 1 by 3.
Okay, let everybody solve this. And if you have any issue, why I am discussing this many examples, because this is the most important topic from week 5. Okay, 2 to 3 problem you can expect from this portion itself.
Sir, r minus 0, minus 1 by 3.
Okay, so 0, so first condition, from the first condition you can exclude 0. Correct? From
Yes,
the
sir.
second condition, f minus 3 is not possible, right? So you have to exclude all those values of x where gx is equals to minus 3, right? So 1 upon x equals to minus 3. So what is the value of x? X equals to 1 minus 3. So r minus 0 comma minus 1 by x. Correct? Any issue in this? Now ask me your doubt. Anybody has any doubt, you can just ask me from this portion. So whatever we have discussed till now, you can just ask me.
Sir, in the example where f of x it is a multiple choice question we had done, where 1 to 5 was correct and 6 was wrong.
Correct.
In that, the second point, range is 0 to alpha. But
infinite.
Yeah, at minus infinity, it is tending to 0. That is why the range is 0 to alpha. Correct, na, sir?
Correct. That
0 to infinity, sorry.
0.
0
We
to
are tending to 0. Yeah.
Tending to 0. Okay, sir.
Any problem? Yeah.
So in second example, for gx.
In which example?
Sir, second example.
Okay, second one. Yeah.
Sir, we can put for gx minus 2 for x value, that we got 0.
Gx? Okay, first tell me, what are the values of x where this function is not defined? 2x plus 4. Are you able to think of any value of x where the function gx is not defined?
No, sir.
No, right? So from the first condition, there is no any value of x.
Minus 2.
No. See, gx at g minus 2 also the function value is 0. So 0 is a defined number, right? Undefined means what? 1 upon 0 or something like this, right? 0 is to defined, right? So you can take minus 2. At minus 2, the function value is 0. That doesn't matter to us, right? So this is defined at all the values. So the domain for this is gx is R. Okay?
Yes, sir.
Done, sir. So we can move to next topic.
So
Sir,
the third question, the g of x is 1 upon x. Can you confirm the range of g of x? It would be like r minus 0, right?
Yeah, this is R minus 0. So it will be defined for all the values minus 0. So there is two conditions. First is you have to take care of gx. So from there you can remove 0. Now we have to take care of fx. So now f of g you are working on. So f of g means you have to take care of all those values of x. So from here you can see that f of minus 3 is not possible, right? You can't put minus 3 here. That means that gx should not be equals to minus 3, right? So gx should not be equals to minus 3. So you have to exclude the value of x where gx is minus 3. That's it.
Yes.
Okay, let's come to the next part. So this is some of the important statement that should be knowing. Okay, remember that, or it's not like you already know. I know, like if f is a 1 function, then f inverse will exist. That you are already aware. F inverse is not 1 upon f. That you are already aware. And f inverse of fx is x, or f of f inverse is x, right? If you have been given two function and then you have to check whether the function in any of the statement wise of question, okay, statement type of question, if you have been given two function f of x and g of fx, then you can say that, right? How will you check whether this is inverse or not?
Composition interchange.
FOG and GOF.
Sir, we can check it
Plus
using the graph
composition
also,
equal
sir.
to
It should be a reflection of.
Okay, solve this question then.
F of g equal to g of f should be equal to x.
Now let me know whether g inverse of gx is equals to x or not. Whether you have to just check whether this function is inverse of each other or not. How will you check? You already know g inverse of gx should be coming to be x, or gx of g inverse x. Check whether you are getting this or not. So in the statement you can get this type of problem.
Sir, don't know the method how to find it.
You don't have to know the method. You just know whether you're able to check whether this function is inverse of each other. See, to how there are not exactly any method to calculate that I can tell you. For example, if we have x minus 5 upon 2x plus 3, and if you have to calculate, you can equate it to 1. And see, there is, I don't know whether this has been taught or not to calculate it, but yeah, one thing I can tell you is you can be given a gx, you'll be given g inverse x, and then you need to check whether these are both are inverse of each other or not. There won't be any problem where you'll be asked to calculate the inverse. Okay.
Okay, sir.
Yeah.
Sir, we can do, I mean to say, we can find the inverse of that.
Wait, check that whether this two function is inverse of each other or not.
Yes, sir.
Okay, so this type of problem you can solve. This is not that difficult. So this way you can solve it, put the value of x here, and then you can get it. You'll be getting the value x, like you'll be getting x, right? But this type of problem can be solved you can equate it to y, and then you can x minus 5 equals to y times 2x plus 3y, and then you can do it, write it here like this. 2xy minus x equals to minus 3y minus 5, and then you can take x common here. 2y minus 1 equals to minus 3y plus 5. Okay, and then you can do it like this. So this is the one method, but minus 3y minus 5, this is minus 5 upon 2y minus 1 equals to x, and then you can replace x and y. So it will be like what? 3y plus 5 upon 1 minus 2y equals to x. This is the inverse of that function. So this is the one method. If you have been given, this is simple. This was very simple to calculate, right? Did you understand, or should I repeat it?
Yes, sir.
Sir, didn't understand how to prove that.
Sir,
How
Okay.
to calculate.
Okay, let me explain it again.
sir,
Yeah.
sir, if a function is strictly increasing, injective function,
Yeah, if a
then
function is strictly increasing, then you will be able to get the
no. If a function is one function, then
yeah
there will be we can
inverse.
calculate always inverse.
Yeah. See, if
Inverse
you have to
always
calculate what?
for injective function, inverse always exists.
Yeah, if the function is a 1, you will be able to calculate the inverse over that function. Okay. See, if you have to calculate, see for this problem, this function fx, you have to calculate the inverse. How will you calculate? You can equate it to y, right? Cross multiplied x minus 5 equals to 2xy plus 3y. Okay. What you can do is you can take out here. So you'll be left with what? X minus 2xy equals to 5 plus 3y. You can take out common x. 1 minus 2y equals to 5 plus 3y. X equals to 5 plus 3y upon 1 minus 2y. And replace the value of x and y. So y equals to 5 plus 3x 1 minus 2x. So this is your inverse, okay, for this function. Okay.
Okay,
Yes,
sir.
sir.
And to check for function, let's for example to check whether this is the exact inverse of this or not. So what you can do is this is fx, right? So I told you, right? If this is f inverse, this is f inverse x. So what you have to do is you have to put the value of f inverse x. You'll be getting x. So your function is what? X minus 5. So you have to put the value of this. 3x plus 5, 1 minus 2x minus 5 upon 2 times 3x plus 5, 1 minus 2x plus 3. So left with what? 3x plus 5 minus 5 times 1 minus 2x. This will get cancelled, right? So you'll be left with what? 2 times 3x plus 5 plus 3, 1 minus 2x. Correct? So this will get cancelled. 3x plus 3x plus
10x.
10x, right? This is 10x. Okay, and now you're left with what? So 6x plus 10 plus 3 minus 6x. So this 6 will get cancelled. You'll be left with 13x upon 13. So you'll be left with x, right? So this is the inverse of that function, correct?
Yes, sir.
Is
Yes,
this
sir.
clear to everyone? Shall we move to the next
Yes,
part?
sir.
Yes, sir.
Okay. So yeah, 5th week is done. I'll again repeat it. What are the important things? Okay. So from week 5, for any given function, you should be knowing it's a strictly increasing, decreasing function. The second part is you should be knowing 1 function. The statement, whatever is given, you should be knowing. Whatever the statement I told you, you should be knowing each and every statement. And the composite function. Whatever I have discussed, whatever the question, I'll be discussing some more questions. Okay, so I'll have to pace out. We have 40 minutes left. Okay, so this is the important portion that should be knowing. Okay, let's come to the 6th week. 6th week, there is not much concept that should be discussed, so that's why I'll directly come to the questions. So you should be knowing, okay, the log ax, you are already aware of how to plot log ax. Okay, if you're not knowing, you should be knowing what is the plot of log x. Okay, you can be given so many questions from log x. This you should be knowing, and this everybody is aware of this laws of log, this 510 log, whatever is there, you should be having, you should be knowing.
Yes, sir.
Okay, because there won't be
Yes,
any
sir.
question directly, but you should be given some equations where you have to use this form.
Yes,
Okay,
sir.
yeah, you were asking something.
Yes, sir.
Okay, let's start solving. So I'll start solving. I have some 5-6 problem that we have to solve, and those are the most important for your quiz paper. Let's solve this problem. Let's start solving from the first equation. So from week 6, I told you this is the portion that should be there in your mind. All the important laws that is there, like all the formulas of log, and you should be knowing what is the plot of log and all. That
So please
if
zoom
that is
out so that I can take a screenshot.
okay, which one? This one?
Yes, sir.
Yeah.
Okay, done, sir.
Done, right? Okay. Let's start solving this one. Solve this problem. And every problem that we are discussing is very important. Everybody should try. At least today you should have to try the question. Just take out your pen and paper, solve this question. Now let me know the number of solution. Okay, not the number of solution, the values of x.
Sir, please show me the loss of log. I'll take a picture, sir. Sorry, sir.
Okay.
Thank you, sir.
Yeah. Solve this question. If anybody has to take the screenshot, you can take out. I'll just wait for 1 more minute. Okay,
Sir, can you
I'll
share?
share this. I'll share this slide. Okay, I'll share the slide on the portal itself.
Okay, thank you, sir.
Hmm.
Sir, from where we can access these slides?
I'll upload on the portal itself. It will be there by tomorrow morning.
Sir, on our dashboards only, na?
Yeah, in the supplementary content will be there.
Okay, okay. Thank you, sir.
Sir, can you please check the question again? I think there is +4.
What?
+4 is equal to 0.
Oh, yeah, correct. You are correct. It should be +4.
X equal to 1.
Okay. 1. X equals to 1. Any other answer anyone is getting?
For -4, it was also coming. Like 2 solutions.
X equals to -4.
No, like the equation, when the equation was -4.
I guess x equals to -4, you'll be getting some complex answer. It will not be real value.
Yes, sir.
It
It
was
will be a
coming
complex
log.
value.
It was coming log 2 plus √2 to the base 2.
Okay, I'll check it. Log. Okay, I'll check it. Any other answer anyone is getting? Okay. How will you solve? How will you start this type problem? How will you start solving this
Taking
type problem?
2 to the power x equal to y.
Yes.
2 to the power x equals to y. Okay. Then y square
4y.
2x 2 plus 4 equals to 0. So this is basically y square minus 4y plus 4. I guess this is y minus 1, sorry, 2 ka whole square equals to 0. Y equals to 2. This is equals to 2 to the power x equals to 2. X equals to 1. Right? So you are getting x equals to 1 as your answer. Any issue in this? Anyone is having any problem in this? Anyone is having any issue in this?
No, sir.
Okay. This is clear to everyone. Now try this one. Calculate the number. You have to calculate the number of solution here. Yeah. So if you have any doubt, you can just ask me for this problem. If you don't have, just move to the second question. This is a question. You have to calculate the number of solution here. So here you have to use all the log. Some of the laws you have to use.
Sir, only one solution.
Okay, one solution. Anyone else is getting? And what is the value of x?
Sir, it is in logs, but should I tell in decimal points?
No, tell me in the log form itself. Decimal, it will be
The log 225 divided by log 5 by 27. Five by 27.
what is the base?
10.
Okay, I guess this is correct.
Sir, any base we can take, no, sir, but
Yeah, any base we can take. Everybody has solved this?
Sir,
Can I
same
solve this?
answer.
Okay. Should I solve this?
Yes, sir.
Yes,
no.
sir.
Okay. How will you start? How will you start? Just let me know how will you start.
Sir, taking log on both the sides.
Take log of both the side. Okay. Now next step. You can use the
Power rule.
3x plus log 3. Correct? What will you do now? X log 5 minus 2 log 5 equals to 3x log 3 plus 2 log 3. Now you can take it here, right? X common log 5 minus 3 log 3 equals to 2 log 3 plus 2 log 5. X equals to 2 log 3 plus 2 log 5 upon log 5 minus 3 log 3. So you have only one solution, right?
Minus 3 point.
Correct?
Yes, sir.
Yes, sir.
Now
Like how
solve
the
this equation.
excuse me, sir.
What? Yeah.
In the previous, yeah. So how some value has been calculated in the end. Someone has told like the values log 225 something.
Log 2, maybe she would have done something else. I guess log, what was the
I
answer?
also got
Log?
this only. That's why I was confused. Like
No, it is the same. See, you can multiply it, you will be getting 2
okay,
log 15. Okay. 2 log 15, you can write it 15 ka square also, right? So it can be 224, 5, right?
The minus 3.2116, sir.
okay, yeah, yeah, okay, so fine, sir, got it. Okay.
Yeah, so in that way you can write it. Now calculate this one. You have to calculate the maximum value of not fx. You have to calculate maximum value of f of gx.
So we had
The
one
log
question
one.
for calculating the number of solutions in one of the previous papers that we discussed today. So that was 2x raised to x equal to 2x. So sir, like instructor,
What? 2x?
x raised to x.
X raised to x.
So it is 2 multiplied by x
2
raised to
multiplied
x
by x raised to x is equals to
is equals to
0.
2x.
Okay, so you are saying that there was a question. 2 to the
Yes,
power.
yes.
Tell me again. 2.
2 into x raised to x equal to 2x. And we were asked to find the number of solutions.
Was this the question? So 2 get cancelled. You will be left with x to the power x equals to x. Was that? This was the question or what?
Yes, this was only the question. And we
Sir,
were
this
asked
was
to
the
find
question, and we have to find the number of
the number
solutions.
of solutions.
So no. So I am not able to get it. Why did this 2 given then? It can be given like this, right?
Yeah, it could have been given like that, but it was given 2x raised to x equals to 2x.
Oh,
And
was
then,
that like this?
yeah. No, it wasn't like that. No brackets were given, sir.
Oh. Then so this is the question, right? Then you
Correct.
can write it actually more, or you can write it like this also, if you are minus 1
But
equal
then
to.
we were actually asked to ask it here in the revision session and like discuss it once with you because we wanted to know the correct approach. We had discussed this with one of the TA today. We had a lecture at 3 o'clock.
So if this is like this, x to the power x equals to x, you can do it in that way also. You can just divide it with the x. You'll be left with x minus x equals to 1. X to the power x minus 1 equals to 1. And then you can solve it x minus 1 log x equals to what?
So we
You're
can
left with,
also take the log both side
yeah, that also you can do. You can
because
take
the
log
base is
both
same.
sides. Yeah, that also you can
In
do.
this
You can take.
question, there is two solutions. Like for any of the method, we are getting only x is equal to 1 is a one solution, but x is equal to minus 1 is also considered. So how to get that is a real doubt.
Yes, sir. Later we came down to the fact that we can maybe like use some graphs or something, and then kind of get the intersection and consider it intuitively that it's minus 1 and 1. But then that is why I got it up here so that we can understand the approach.
No, you can solve it. 3 different methods can be there. One, two, you can take the log on both sides. If you are taking the log on both sides, you can take x ln x equals to ln x, right? Or you can, okay, but that, okay,
So
so
for
this,
log only one value will occur.
what?
Like for taking log, it will only show up only one value, that is like x equals to 1. But how minus 1 came, that's the main question.
Can you send me the screenshot of that question? Because I'm not able to get the idea why this 2 was given. So there must be something more
The
information or
minus
something else.
one, so minus one is itself not satisfying the equation.
Yeah, so no. So can you send me the screenshot once? Minus 1 to for sure is not satisfying.
Sir, this
Send
equation minus 1
the
is satisfying.
Yes,
Like
yes, it's
minus 1 to the
satisfying.
power minus 2.
No. Okay, can you send me the screenshot once? Let me
So
check
I've
it.
sent the
What is it?
link of that PDF itself. We were sent this by ma'am. So if you could go here and it's question number So if you go to page 47,
Page number
47, page 47.
How can I? Okay.
I have sent you the question screenshot.
Is the question or no? Yeah, okay. Okay. Hey, what is this? Okay. Okay, whatever you have said is correct. So let's go there. No. If you have been given 2x to the power x equals to x, right?
2x.
2x, so okay, it can be x to the power x equals to x. And if, let's for example, you are taking, we are just dividing this. X minus 1 equals to 1. This is the one. So it is x minus 1 ln x equals to, this will be ln 1 is 0. So, okay. One method what I can have is, one so I can solve with the plot. I can plot x equals to 1 and I can plot y equals to x to the power x. From there I can get two solutions for sure. But I need to solve it from the
Sir, if you like put directly like x equals to -1 as well, it solves the equation like the upper one.
one is like you can plot, if you're plotting x to the power x, you'll be getting something like this, I guess. So it will be must at x equals to 1, so it should be cutting at x equals to y equals to x to the power x. At x equals to 1, it will be cutting x equals to there, it should be somewhere here. From the log, if you are solving, I think you are getting only one solution. But whatever you have told, if you are using the hit and trial method, then you can get the two solutions. I need to check it. Because if you're solving like this, there you are getting only one solution, right?
Yes, sir. By log, it's only one. Yeah.
Or am I doing any mistake?
No, even like we tried with log, it's only one
When
solution.
we take log, we assume that x is greater than 0. So we'll
Yeah.
get only one solution.
Yeah, so because we assume it, because if you're plotting also, you're not able to get. So because you are assuming x is greater than 0 always in the log, so that's why you're getting one solution from there. X equals to 1, you're getting one solution, right?
Yes, sir.
But the other
Sir,
solution,
can we also solve it like this? Mm, just like x power x is equal to x power of 1 and comparing both sides, then x is equal to 1. The second
that
method.
yeah, that is the hit and trial method that you can use it. But if somebody is like use some, see, by plotting also you will be able to get the equation, I mean two solution. The only method that can help you is hit and trial. So this can be done, but it should be there like, okay, because there was no condition was given on x. Given on x, as x can be any positive and negative values also, correct? So if x and can, because while we are using the log method, we were just taking care of the positive values only, right? Correct? So
Yes,
what you
sir.
can do, exclude x minus x equals to 0, right? Here if you are taking x common, what is the left with x, and this is x, right? X minus 1 minus 1 equals to 0. So if you're solving like this, though, then what are the values you are getting? X to the power x minus 1 equals to 1, the 1, and then either x equals to 0. So if you are taking x minus 1 ln x equals to, this will be 0 basically, so x equals to 1 from here. But the problem is you can't solve with this method. I need to check this, because from the log, because you are already, there is only one method, then hit and trial, there is no other method that we'll be using, because log from log method you'll be just getting one solution, right? And that because x will be positive there. I need to check this, and then I'll be discussing this
Sir, we are
problem,
getting
and
two
maybe
solutions, sir, if we are doing like this.
what
Sir, we can get two solutions if we follow the same procedure as you did, sir.
yeah, but 0 can't be the solution, right? 0 to the power 0 is not defined, right? So you can't
Yes, sir.
take 0 as solution. So that's why I was not using that method, because see, you can do it that way, minus x equals to 0, x you can take common x minus 1 minus 1, but x equals to 0 is not the solution for this
Sir, we
case,
can do
right?
it that way, and then we can eliminate the solutions which are not satisfying the domain of the question given, sir.
Yeah, but the again the issue is x to the power x minus 1 minus 1 equals to 0. X equals to 1 can't be the solution for sure. Then the other solution can be, you have to equate it this equals to 1, right? So x minus 1 log x equals to 0, right? From here also we are getting Either this can be 1 or this can be 0 or this can be 0. This can't be 0. So from here also you are getting x equals to 1. Correct?
Yes, sir.
So x equals to -1 is the only method is to hit and run. Or maybe I'm missing something. I need to check up on this. Okay.
Okay, sir.
Yeah. If anybody else has a solution for this, you can just let me know, because I thought this can be the approach. From both the approach we are getting the same answer. Okay.
Sir.
Yeah, so you're solving this problem. Everybody solve this problem.
Sir, 0 is the maximum value, I guess.
Everybody has solved. What is the maximum value for this one?
It's -3/8.
So if you'll calculate the maximum value for this gx, you'll be getting -3y.
No, sir. Sir, the value of x for which the g of x is maximum is -3/8, but the value y value is 41/16.
Okay. Yeah, I guess you're correct.
Sir, but there is a problem, sir. In this question, I was not able to find out the maximum value because f of x is equal to log that is to the base 3/8. No, sir. So 3/8 means it is a decreasing function. So mod x should be the least value. So that
No. Just asking you have to calculate. Okay, so whatever the value, see here, what is the value you are getting?
16.
41/16. So yeah, so you can get the value log 3/8, log 3/8, 41/16.
Sir, but here this log 3/8 is having base less than 1, no, sir. So it will be decreasing function.
Yeah,
So
it is a
to find
decreasing
out
function.
to find the maximum value, we should substitute a value which is the least, no,
Correct.
sir, least.
Yeah, you're correct. So to calculate the maximum value, right? So this was a decreasing function. That's why you have to take any. So this will be something like this: log 5, 41/16. So you are absolutely right. So it can't be a decreasing function, because if you are taking the maximum value, you have to take the minimum value to get the maximum, right?
Yes, sir.
Yeah, right. Is this clear to everyone? What was the mistake that we did here?
So can you solve it?
Yeah. So if you have this question, how will you calculate the maximum value? This quadratic question will go upward or downward?
Downward, sir. Downward.
Okay, so if this is going downward, that means the function will be having a maximum value. So what is the maximum value? What is the value of x minus b by 2a? And what is the function value at that point?
-3/16.
-3/16 or -3/8?
-3/8, sorry, -3/8.
41/16 will be the y value. So this is x and this is y. Okay, this is the maximum value. But earlier it was 3/8. So earlier it was less than 1. That means that was a decreasing function. Okay, for a decreasing function, you have to get the maximum value. So you will be needing the initial point, right? Because we were having the maximum value, right? So that's why it changes to some value alpha greater than 1. So that now if you have to calculate the maxima, you can put the maximum value of this function. And if you're able to put the maximum value, you'll be getting the maximum. Okay, that was my mistake while putting the question. Okay, so if this type of problem will be asked, you'll be able to solve, right?
Sir, please explain once again.
Okay, so what I was saying is, okay, let me simplify this problem. Now this is log 41 16 of x. Okay. So now this question was, you have been asked to calculate the maxima value of f of gx. Okay, so this has been given your function and this is the gx. To calculate the f of g, maximum value of f of g, first you will calculate the maximum value. And if you are able to calculate the maximum value of this function, you just have to put it here to get the maximum value, because I told you log ax, where a is greater than 1, is a increasing function, right? Increasing function. So if you are putting a value, whatever the value you are putting, you'll be getting the maximum value itself. Okay, so log doesn't do much. Okay, whatever the function value you are giving to it, it will be giving you directly the maximum value at that point. So what we'll do is, you have to calculate the maximum value of this gx. So whenever you have been asked to calculate the maximum value of f of g, you have to just check, you have to calculate the maximum value for this function, and this you can do it, right? If you have been given a quadratic equation, you can calculate the maximum value. And if you are able to calculate the maximum value, whatever the maximum value you are getting, see, first you will calculate at what point it is giving you the maximum value.
Yes, sir.
Right?
Yes, sir.
And if you are able to calculate the maximum, the point at which you are getting the maximum value, see, here you have to write, you have to calculate the maximum value of f of g. So f of g will be what? In this function you have to put, right, in the log 41 upon 16, you have to put gx, correct? This is what you have to do. And if you are able to put the maximum value of this gx, you will be getting the maximum value of this function also, as this is an increasing function. So you just have to put the maximum value of gx. So maximum value of gx is what? 41 upon 16. So if you are putting 41 upon 16 here, so you'll be getting what? 1 as your answer. Correct?
Yes, sir.
Yeah.
Yes, sir.
Is this clear to everyone?
Sir, I understood up to like this log. I did not understand. Sir, kindly repeat the last two steps.
Okay. 1 minute, just I was for water. Okay. So what I was saying is, if you have been given to, you have been asked to calculate the maximum value of f of g, right? And for fx is given, gx is given. So if you have been given the fx as log of 41 upon 16 ka x, this is the function been given to you, and the gx is been given. If you have to calculate the maximum of f of gx, correct? How will you calculate this function? How will you calculate the maximum value of this?
Sir, but f of x, can you go over? Like it was saying something else.
Yeah, this is like 41 upon 16x.
But we started with another question, correct? Log of 3 by 8, log of 3 by 8, and
Yeah, that was a
x
different.
mod.
Yeah, that was. Yeah, we started with a different function.
Yeah. But g of x was same for both the questions.
That is. So why did I change this? Because this function was not correct.
Oh, okay.
According to
Sorry,
whatever.
I did not follow that. Then it's fine, sir. Koi issue nahi. Thank you.
It was like the double log, which when you changed it, log 5, how will you do that?
See, log 5, if it is log 5 also, that is fine. So if you have this one function also, gx, right? So whatever the, if you have to calculate the maximum, basically you have to calculate f of g of maximum, right? So if we are able to calculate the maximum value for this function, what is the maximum value for this function?
41 by 16.
41 by 16, right? 41 by 16. And your function log is your fx. So you can directly put it fx, this one, right? To get the maximum value. Because there is no value, any gx that is greater than 41 upon 16, right? So if there is no gx that is greater than 41 upon 16, so that value you can put it here directly, because you already know that log function is something like this. Okay, so if you have this value was the maximum, because this gx will work as a x for this f of gx, right? If you are able to get this 41 upon 16, so at this point your value will be maximum, right?
Yes.
But if that was the case, if this was the case, earlier we were taking some value where 3 upon 8 was the function, right? But at that point, we were not getting the maxima, we were getting the minima. Right or not? So that's why I've changed it to 5x. Base greater than 1. That's why I've changed it. So whatever C told in the starting, C was totally correct. Because if you have to get the maxima of that function, 3 upon 8, then you have to take out the minima of this function, right? Because minima of this function, because minima will be some function, right? So minima of that function, and that will work as a maximum for that function. That's why I have changed it directly to this function, so that there won't be any confusion.
Sir, if
Is
we
it
change
clear
the
to
function
everyone?
like log 5, sir, hello?
Huh?
Sir, if we change the function like log 5, log 3 by 8.
Log, if you are changing to log a where a is greater than 1, then all are increasing function.
Okay.
Okay.
No,
But if you are
saying,
changing, if your a is between 0 to 1, then it will be a different, like a decreasing function.
Sir, what I'm saying, sir, if you change the function like log 5, log 3 by 8, like one part is increasing and other part is decreasing. Log 5.
Then it will be a bit complex one, right? If you are taking log 5, log 3 by 8, okay,
of
then
GX.
this is a decreasing function, right? Correct?
Yes.
And if you have to calculate the maxima for this, okay, so whatever the function, so if you have to calculate the maxima, so this log 5 will not be doing any, because this is an increasing function, but this is a decreasing function, right? For this decreasing function, this is a decreasing function, what you should be needing is, if you have to calculate the maxima to get this, for this maxima, this should be maxima, but according to this function you will be getting the minima. Are you getting my point?
Yes.
So that will be a big complex one, but that is solvable. Like according to the problem, if you will give me the problem, you will be able to solve that. Then you can check it, what value should be putting it here. But there won't be that complex problem in the exam. Okay.
Yes, sir.
Yes, sir.
Okay, so I guess we are have discussed all the problem. Okay, one problem is left, I guess. Yeah, let's solve this problem. Can you tell me which are the points not in the domain of f of fx? You have to basically tell me the domain of this function. F of f.
R minus 5.
5.
R minus 5.
5.
I guess there must be some other value also.
So 0.
26 by 5.
0, 5.
26 by 5.
Okay. So what are the two conditions that I told you in the starting? If you have been given fx and gx, what are the two conditions I told you? The first condition was what? You have to exclude all the values of x where gx is not possible. So the first point you have already done. So for this fx, the same thing, fx and gx both are same. So here you will be doing this. So you are removing 5. But the second condition, what did I say? You have to remove all those values of x where gx, whatever you are calculating, is not in the domain of fx, right? Here fx and gx both are same. So you have to remove what? F of fx. So you have to exclude all those values of fx where this is equals to 5, right? Because f5 is not possible. Is f5 possible? Is
No.
f5 possible? No. So you have to exclude all those values of x where f5 is 5. Okay, so 1 upon x minus 5 is equals to 5. So you have to remove all those values of x where this is holding. So 1 equals to 5x minus 25. So this is 26 equals to 5x. So x equals to 26 upon 5. So you have to remove r minus 5 comma 26 by 5. Okay.
Yes, sir.
Okay, sir.
Is this clear to everyone?
Yes, sir.
Yes, sir.
So do not do any blunder in the exam. Yeah.
Sir, my doubt in log x is not clear. Can you take one question from it is activity? It is activity 6.1, question number 4.
Okay, that I
Basically, what is
can't
not
take
clear?
it. Maybe we can discuss in the next session because I what I can do is like
I will tell the question.
yeah. What is that question? Can you tell me? What's your doubt there?
Basically, it is log x plus log to the base, base in the base x plus 1 by x minus 1 to the power something is given.
X plus 1 upon x minus
X minus 1 to the power x square to the power x square plus 1 by x minus 1. It's a question.
Okay. Okay. Can you repeat it? Log base is what?
X plus 1 by x minus 1.
Okay,
Yeah.
this is base now.
Then the power is x square plus 1
X square plus 1
divided by x minus 1. So I have doubt in this the domain is considered to be minus 1 to 1. So I'm getting minus 1 to 1, but the doubt is that minus 1 to minus 1 and 1 are included. So log according to this base I'm getting that x plus 1 x minus 1. So minus 1 and 1 should not be included, sir, no, because x plus 1 by x minus 1 should be greater than 0, right?
This is x square plus 1 upon x minus 1 should be greater than 0.
No. Yeah, that is fine, sir. But x plus 1, what is in the base? That should also be greater than 0, right?
Base.
Yeah. No. Log x plus
Okay,
1 by...
this should be not equals to 1. Yeah, this should not be equals to 1.
Sure, greater than 0 because the log has a range from domain from 0 to infinity, right?
So she's saying about the whole base, the a value. A value should be greater than 0.
So basically this is ax, right? So your x is...
Sir.
Okay, so a, what is the condition that you apply on a?
A should be greater than 0 because the domain of the
Okay,
log
a is
0
greater
to
than
infinity.
0 and a is not equals to 1, correct?
Yeah. So
This is the
A is greater than 0. I'm not getting minus 1 should be excluded. So it is included in the question. So my doubt is that.
X equals to 1 is included.
Yes, sir.
How is this possible?
That's the thing I'm asking.
Sir, the question is asking about where the function is not defined.
That x equals to 1 will not be defined. From here itself you can see that, right? X equals to 1 is not possible.
It is not defined. It is not
Even
defined
for
in the
this
interval
also, even
minus
for
1 to
this
1.
case also. Yeah.
Okay, sir. Thank you, sir. I got the question.
Yeah. Okay, so I guess we have discussed all the problem. So if we are have attended it carefully, I don't think so there will be any problem from these weeks. But you just go and solve previous term paper and graded assignment. You have time. and just solve this type problem, whatever we have discussed. And one question that you have solved, if I'll get I'll just work up on that, and then I'll post it on the discourse. Okay, I have some confusion in that question. Okay,
So the
is this
next
clear to
revision
everyone?
lecture, so the next
Sir, what
revision
about the
lecture
week
will be
7 and
taken by
8?
you.
Week 7 and 8 will be taken care by someone else. Yeah, he'll be doing that. I don't know when is that next session, but it will be done
We are
by somebody
facing a
else.
lot of difficulties in solving calculus.
Okay, so
Sir,
the one thing I can tell you is like the paper is like pretty simple. If you are just going through and able to solve the previous term paper and at least solve the activity problem, all the activity problem, basic concepts should be clear. And I don't think so. I can't find any reason that you'll not be able to solve. There won't be any difficult function that I can assure you. Okay, all the trigonometric function are also very simple, sine, cos, that's it.
Sir, today afternoon 3 to 5 there was a session conducted, but there is no YouTube link. We could not
There
attend
won't
during
be,
the session.
but I guess the recording will be there. But I hope there won't be any YouTube link that will be there for that. But
So
recording will be.
where do I see the recording, sir, please?
I guess that should be
YouTube, sir.
present in the calendar. I guess.
YouTube,
No,
sir.
it is not available, sir.
Not there.
YouTube, it is not there. Why?
Yeah.
Okay, somebody can help her out.
Today, ma'am said that it will be like uploaded by tomorrow or so, and it will be in the calendar link itself as a attachment.
That
So they have
is
updated.
what I also know. That will
Already
be
uploaded.
attached to the calendar.
Drive link is available.
Okay,
Yes, sir.
can
Google
you
Drive
share
link is available.
Okay, thank
please,
you.
please share it with like everybody else. Yeah.
Another
Okay.
query, sir. Are the marks of both the quizzes going to be considered for computing the final grade in term 1?
Yeah. Basically, all the quiz scores are considered for the final grading. Like there is some formula. I hopefully you'll be aware of the formula that has been used to calculate the final marks. There is some weightage of quiz 1, some weightage of quiz 2, and there is a very high weightage of final quiz.
Okay.
So that you can check it.
By final quiz, you mean the final examination,
intern.
right?
Yeah, the intern. There is some 60 or 40% weightage, and then there is some 30%, 30% weightage. Or like there's like for each and every course
Sir,
there's
40,
some
30, and 20.
I guess
Yeah, 40, 30, 20, 30 is for one case, and the other case would
Sir,
be
20 for
60 and
first,
max
30
of
for second, and 40 for last, final.
In one case it's 80 max, and in second it's 90 max.
If one
For
didn't
90
appear
max
for any one quiz, then it will be
reduced
calculated
to
in a
90.
different way.
Yeah. If you are just appearing for one quiz, then the method would be different. Yeah, basically it's based of two. Like there is two formulas would be there, and then depending upon your performance, so it's best that you should be attempting all the quiz, and then your both the formulas will be used to calculate a mark, and whichever is the best will be given to you. Okay.
Okay, sure. Thanks.
Yeah.
Sir, I have a doubt in your week 5 slide.
Yeah, go ahead.
The last, can you just scroll to the week 5 last page? I guess you missed out one point there. Week 5.
Week 5. What? Yeah. What was that?
The points that you give up more of it. It's up. Yeah, this one, number 5.
Yeah, I just told you that if f and g both are 1, 1, then f. No, then f of g will be 1, 1. It's like mistake. But the inverse is not true. Yeah, f of g and f g of f will be 1, 1. This is important. So 5 statement I just wrote it. You should be knowing this 5, 6 statement, whatever I told. Okay. This is what, that's why I written here, some important statement that should be knowing. Okay. But the inverse is not true. If f of g has been given that this is a 1, 1, then you can't say. Okay.
So what inverse? I mean, this f of g and g of f are correct, right?
Yeah, this is f of g. This is f of g
And
x
g of x
and g of fx is 1, 1. If f
1, 1.
of g has been given as 1, 1, then this will be.
Yes, sir.
This is what has been written. Okay.
So can you take a question from sequence?
Can you take a question?
Sequence from sequence.
Seconds will be discussed. There we have 1, 2 more hours for the revision session. So there we'll be discussing. I guess whoever will be discussing will be discussing the problem from those last 2 weeks. Okay. Don't worry about that. I guess tomorrow only you have a session, or day after tomorrow. I didn't check the calendar. Yeah. Okay. But if you have further doubts also, you can just, I have given you the contact number, I guess, like some people. So you can just contact me on the WhatsApp or yeah.
Sir, once again,
before the exam.
So once again, share your contact number, please.
Yes.
Yeah,
No,
please.
first you
It
have
would
to
be
mail
great.
me, then only. I can't do it here because this is going live streamed on YouTube.
So
Okay.
your email ID.
So can you share your email? Yeah.
Vishal@study.iitm.ac.in. Vishal
Okay.
yeah. So you can just mail me. I can just contact with you. I have last meeting also I've told you if you want me to have some other session also, we can just solve some queries, and before the exam if you have a time, I have some other courses also, but okay, after Wednesday I'll be free on after Wednesday. Sorry, after I have a session on, I guess, Friday, I guess, for the other courses. So I'll be free on Saturday. You can mail me, message me, whatever you want to do.
Sir, Vishal at the rate of?
study.iitm.ac.in. It's similar to your mail ID, just that in spite of your roll number, you can just write it Vishal.
Okay, sir. Thank you. I appreciate it.
Sir, is it @ gs.study or just study.itm.ac.in?
@study.iitm.ac.
Okay, sir.
Okay, then all the best for your exam, and I guess.
Patient on chart, sir.
What?
I had patient on chart, sir. Email ID, sir.
I didn't got any, but okay.
One last query. Syllabus for quiz 2 would be till week 8, right?
Week 4 to 8. Hey, do not send me from your personal mail ID. Please use your ITM online degree mail ID. Okay.
Sir, I have not got the
Sir, we
ID
haven't
email.
got the mail ID yet.
Oh,
We
okay.
did not get the mail.
Okay.
Vishal, we don't have the email ID. Plus, also we'll don't have access to Discord and all.
We'll get that after the first this end term.
Okay. Okay, that's why I was always thinking. Okay, why people are not using? Okay, got it. Okay, you don't have the mail ID till. Hmm. Okay, got it. Okay, I'll share it. Okay, then I guess this 2 weeks is clear, right? I got one question I have to discuss, and that I'll post it on the discourse,
Okay,
or
sir.
maybe I'll just work up on that. What was I missing there? Else, I guess
Okay, sir.
week 5 and 6 we have discussed everything, and hopefully I can't find a reason that you'll not be able to solve any of the problem. If you have attended the session nicely, hopefully you'll be able to solve all the problems. At this solve the previous term problem, 2 term paper, and some of the graded assignment question, not all. Some are really difficult that you can, if you don't have much time now, you can just skip that. But at least solve the previous term paper. Some of the activity, I guess I didn't told you the activity question number, right? I didn't told you that. Okay, but the problem is that my laptop is also switched off, so I can't get the information. Okay, what I can do is, yeah, some activity questions you can solve it. The topics, whatever I told, from those topics, solve the activity problem also. Okay.
Sir, there are some word problems type questions in
Sir.
week 5 and week 6. So, sir, they are important.
What type of problem? Comprehensive. Okay, so comprehension type maximum you'll be getting one question. Okay, comprehension type of question from whole 4 weeks. So that you have to, that question can be in some 5-6 lines, that you have to just read it. If you are able to read it, if you have that patience to just read it, you'll be able to solve it. Okay, that problem will be the most simplest problem for all the week. So basically you have 11 or 12 problems. Some problems can be subpart also. So yeah, so this is how your problem the QP is. So 12 problems and some problems, so all together you'll be having some 17-18 problems that you have to solve it, but most of them are very simple. Even you'll get stuck maximum at 1 or 2 questions. Everything else is very simple.
Also, like I had another query. So, what about the tutorial questions? Like, is there any chance, like, because the level of questions in tutorials is higher than the questions which is in the practice assignments or graded assignments?
So what I told you is, the first priority should be whatever the question we have discussed. Then it should be going through the QP, previous term May and January term paper, and then if you have a time, then go through some of the activity questions. Okay, and further also you have a time, you can just go through the tutorial, but that should be your list priority. Okay.
Okay, sir.
Yeah.
Thank you so much.
Yeah. Thanks everyone for joining the session, and all the best for your exam.
Yes,
Thank you
sir.
very much. Sir.
Okay. Thanks. I'll just
Thank you,
ask
sir.
them to close. Yeah.
Thank you, sir.
Thanks.
Thank you.
everyone.
Really appreciate it. Bye.
Bye.
Bye, sir.
Bye everyone.
Get out.